Guys, welcome back to L-Level Maths with Daniel Dallas. This is all about differentiation rules. You can see constant rule, power rule, sum and difference rule, and constant multiple rules. Alright, I'm gonna show you how to prove each of the rule. And here is the first one that I'm gonna start. It's constant rule. Let's get started. So, in other words, if your function fx, simply your function is the constant, that means f from x equals some c, where c actually is a real number. You need to prove that the derivative is going to be 0. So f prime is going to be 0 if f is c. Okay, so how it works? First, I want to show you just using differentiation from first principles, and all those proofs I can use those rules. And I'm just going to say that f from x, just by definition, is going to be the limit when h is very small. So you've got fx plus h minus fx over h. In other words, it means that fx plus h and fx are both c. So that's why you'll simply get c minus c over h. In other words, you'll get f prime from x equals 0. Okay, so the proof is done. And theoretically and graphically, we can also show that if this is f, this is x, and you just want to build the line, which is the constant. So in other words, you take the level of c and put this line down that goes through the c. You see that no matter which 2 points you'll take, in trying to measure the gradient between them, for example, A and B, you understand that if you want to measure the gradient of that line, gradient L, it's going to be change in f over change in x. But the function value is not changing because it's always c level. So that's why you'll have c minus c over delta x, where delta x is the horizontal step between those 2 points. And you understand that the gradient of horizontal line is always 0. So that's how you can apply to derivative as well, because in your case, derivative and gradient will be the same. It's done. See you next video about power rule differentiation.